Don't forget to subscribe and ring that bell.
Hey, welcome back. We are going to continue the 2012 AP Calculus AB practice exam that College Board put up with, 10 years ago. We are going to do free response question number 5. And don't cry. It's okay if we don't get a calculator because the algebra is typically easier. Okay? Subscribe, ring the bell, make some comments, like the video, all that jazz. Let's get started with free response question number 5. Number 5 states, the rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time t equals 0, when the bird is first weighed, its weight is 20 grams. If b of t is the weight of the bird in grams at time t days after it's first weighed, then dB dt, which is the derivative or change in rate of b, is 1/5 times 100 minus b. Let y equals bt be the solution to the differential equation above with initial condition b of 0 is 20. That makes sense because at time 0, it's 20. Remember, this is a coordinate. It's like our x and y, or in this case, t for this and maybe b for y. All right, A is asking, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. First, let's understand what they're asking. Is the bird gaining weight faster? If B is the weight of the bird, is it gaining weight faster? Meaning, is that weight changing? Is the weight, rate changing faster? So is the rate of weight, which sounds weird to say, changing faster? That's the derivative. That's this thing right here. That's what I'm going to use. It's nice that they gave that right to us. Okay? So is that rate faster or bigger at 40 grams when the weight or the B value is 40 grams, or when the weight or the B value is 70 grams? All right, so that's what we're really doing. So let's start with the 40-gram version. I need to take my derivative or my rate and set my B equal to 40. All right, and let's evaluate this. So this is going to give me 60. 1/5 of 60 is 12, and that's in grams is the weight, and times day. So at the moment, the bird is 40 grams. Its weight is changing at a rate of 12 grams a day. We need to do the same thing with 70 now. Our derivative, or our change in rate of the weight at 70 means my B value is 70. This is 30. Still got to multiply it times 1/5. That is 6 grams per day. Now, obviously, 12 is bigger than 6. But see this explain? Explain your reasoning. You can do it simple as long as you are specific. Specific does not need to be lengthy. And again, the way I write it might be different than the way you write it. There are always 1,000 different ways to write these things. So first, let's answer the question. Is the bird gaining weight faster at 40 grams or 70 grams? So at 40 grams, the bird is gaining weight faster. That's the answer. Boom, right there. And I'll make that a comma. Since, okay, and now should I have to say the rate of weight or the dB dt? I can put dB dt. That would be easier. Since dB dt is larger, I'm going to put 12 at of B equals 40, then B equals 70, which was 6. I mean, that's it. I mean, if I want to be more specific, is larger, I can put 12, and I can put grams per day. I can put that here and here, okay? And I can put, when B equals 40 grams or 70 grams, okay? That's a little bit more specific, the labels, because that puts, the labels puts my explanation more in context of the problem, okay? But that's it. There are 1,000 different ways. I could have written 4 more sentences to get really, really specific, but don't be too general to the point where, you know, it doesn't pinpoint your exact situation, the 40 and the 70 grams. All right? 5b. Find d2b over dt2, which is, okay, find the second derivative of b, all right, in terms of b. Use the second derivative of b to explain why the graph of b cannot resemble this graph below. So the real graph of b, cannot be this graph, okay? And we're going to have to use that second derivative that we come up with in our explanation. All right, so first of all, let's write down, I should say, what the first derivative was that they gave us from part A, or from the beginning of the problem. That was 1/5 times 100 minus b. Okay, I am going to take the derivative of this. All right, that's the first derivative of b. I need the second derivative. So I need to take the derivative of the first derivative. And here we go. This is a constant, so I'm going to leave it alone. That's being multiplied. The derivative of 100 is 0, minus the derivative of b is just 1, but it's 1 db dt. Okay, and if I want, anytime I subtract anything from 0, the 0 goes bye-bye, it's really just negative db dt. All right, and what I end up with is negative 1/5 times db dt, all right? Because a negative times a positive would result in a negative. All right, but we need this in terms of b. So I've got to bring the b variable back into this expression, okay? Because right now, this is my second derivative. So what I'm going to do is, whatever db dt is, I'm going to put in there. dB dt is this. So I am going to take this expression, which is what dB dt is, and I'm going to put it right there. Okay, so negative 1/5 times 1/5 times 100 minus b. Now, I can get all sorts of crazy, but the only thing I'm going to do to simplify this is I'm just going to multiply these two together. I got negative 1 over 25 is 100 minus b. Okay, this is my second derivative right here. Simplified. I could distribute that negative 1/25 into the parentheses, but let's not get too crazy. Now, second derivative represents, in terms of this graph now, second derivative is concavity, right? All right. Now, keep in mind, I do not have t in this equation. I have b. This is supposed to be the graph of b. And we're supposed to say why it cannot be that graph of b. So b, I really have my y value. So let's take a look at the two y values they give us. And that's what we're really going to use to drive home the fact that this graph cannot be the real graph of b. See, they give us 20 to 100. Okay, if I put any value between 20 and 100 into my second derivative, Look at this is a positive concavity, right? That's a smiley face. I should have a positive, okay, second derivative there. And that's what I'm going to use. So as I look at my expression here, or my second derivative, for any value between 20 and 100, okay, as I look at the second derivative, my d2b over dt2 is negative. If I put any number here between 20 and 100, okay, 73, okay, I get a positive value in the parentheses, but a positive times a negative will give me a negative value. So any time between 20 and 100, any b value, my overall second derivative is negative. The graph is concave up, or a positive second derivative. So this cannot be the graph of B. Sorry, I was running out of words. I'm writing more than I normally like to, but I'm trying to be specific, okay? For any value in the interval between 20 and 100 for B, my second derivative is negative, according to the equation I came up with. The graph, it's concave up, or positive second derivative, so this cannot be the real graph of B, and that's what they asked us to discover. All right, get cozy, settle in. This is going to be a little bit of work. Not tremendously difficult algebra work, but it's going to be more than we've done before for A and B in this question 5. Use separation of variables to find y equals bt, the particular solution to the differential equation with the initial condition, all right, with the initial condition, b of 0 is 20. So again, this is my t, or my x, if you will. This is my b, or my y, if you will. So that's an actual coordinate, 0, 20. So when I come up with an equation and it has a constant in it, plus c, I'm going to have to figure out what that c value is using that initial condition. All right, so first of all, I know that dB dt, this was given to us, is 1/5 times 100 minus b. All right? Solution to differential equation. Separation of variables, meaning I got to get my dB on one side with my b variable, and I need to get the dt on the constant with the other side. So what I'm going to do, okay, is I'm going to divide both sides by 100 minus b, or multiply by 1 over 100 minus b. Either way is the same. Let's use multiplication. Okay, so this is bye-bye, and this is bye-bye here. And let's do this to clean it up a little bit. So now, let's multiply the left side by dt. We'll multiply this side by dt. So let's rewrite what we have right now. We have 1 over 100 minus b dB equals 1/5 dt. Okay. I need to integrate both sides to get rid of those dummy variables. All right? Integrate this side. Integrate this side. This is the easier. That's just 1/5 c. Well, actually, I lied. My variable is t. 1/5 t plus some constant. All right? That's going to equal, oh boy, let's do a quick little u sub here. I'm going to say u is 100 minus b. So du is just going to be negative dB. Well, I only have a dB. I don't have negative dB. So if I multiply both sides by a -1, this gets with this, and I have dB equals negative du. Let's do our substitution. The integration of 1 over u is going in for this. I'm going to put negative du, negative, put that on the outside, du in for my dB. Know your rules. The integration of 1 over u is the ln of u plus some constant. All right? Don't forget, I need to negate it. All right? So that's what we end up on the left side. The last thing is we need to put our u value back in. All right? And our u was 100 minus b. So I now have the negation of the ln of 100 minus b plus some constant is going to equal 1/5 t plus some other constant. All right. Well, let's start by getting rid of this constant here. Subtract constant 1 from both sides, and I've got the negation. I got the negation of the ln of 100 minus b equals 1/5 t. If I have a constant and I combine it with another constant, it's still a constant. All right, it's still a constant. And in fact, at this point, I'm going to multiply both sides by -1 to get rid of this negative sign here. So I multiply this side by -1. So now I've got the ln of 100 minus b that's positive equals -1/5 t. Whether a constant's positive or negative, it's still just a constant. I can say plus a -3. It doesn't matter. Okay, so that's what I'm going to leave there. Now, my friends, I need to get b alone. I got to solve for b. So what I want to do is put a base e to both sides. These cancel. Let's do this up here now. So now I have 100 minus b equals, all right, e to the -1/5 t plus c. Know your rules of exponents. How do we get a situation where we have a base where we're adding exponents? We had to multiply bases first so I can add exponents. Look at the bottom left of my screen here in gray. If I have x squared times x to the 5th, that's x to the 7th because I had to add 2 plus 5. Okay? Well, my common base here in the top right is e. That had to be e to the -1/5 t times e to the c. That's how I added them. Okay? Know your rules of exponents. By the way, e is a constant, 2.718, etc., etc. A constant raised to a constant is just a constant. Woo! I told you to hang on. So it's some constant times e to the -1/5 t. Yeah? Yeah? You with me? Good. Good, good, good. All right. Well, I mean, what else do we got to do here? Let's just subtract 100 from both sides. Man, we are working. Boom. -b equals some constant c times e to the -1/5 t minus 100. Don't know what that purple little decimal thing is there. Let's get it out of the way. Now, I mean, if I wanted to, really. No, I guess I can do this now. Let's put our, okay, let's clean this up. Before we substitute in, let's clean this up. Well, again, multiply this side by -1, multiply this side by -1. Okay? And we end up with positive b equals a constant times a negative. It's still going to be a constant. And this will turn to plus 100. All right? Now I take my initial condition, and I got to find out what C is. Okay? They want my equation B, but they want the exact solution using this condition at 0, 20. Okay? My B is 20, my T is 0. Okay, so 20 should equal some constant times e to the negative 1/5 times 0 plus 100. So let's simplify and solve for C, shall we? Here we go. Anything to the power of 0 is 1. So C times 1 is just C. Plus 100 equals 20. All right, well, that means if I subtract 100 from both sides, negative 80 equals C. Oh my goodness, we are almost done. We've just got to use our equation and put a C in. I don't know why that always pops up like that. It drives me crazy. We've got to use our equation and just put our C in. This is our equation right here. I told you we were going to be doing a lot of work. You didn't want to believe me. So B equals, it used to be C, but now our C is negative 80. E to the negative 1/5 T plus 100. Whew! I told you it was going to be a lot of work. And that's C. Thank goodness. All right, so let's take a look at all this work we did to get one answer. It's absolutely insane. And on top of that, thank goodness, there is no D. All right? So, had to separate them. Okay, had to separate them. We did a U substitution when we did the integrals of both sides. Okay, had the ln, had to bring in the E to get rid of the ln. And it was algebra. It was a lot and a lot and a lot of algebra. Remember back in the day when I had to re-explain this? Oh, good times, man. Good times. Hey, thank you for sticking this one out. This one was challenging. This one was no joke. If you got through this one, you're fine. Okay? Man, I hope I didn't scare you off because I still got to do a video for free response question 6. I will see you then. Bye-bye.